Okay, why, yeah, I don't know what I did with my hands, but welcome to another episode. And in this episode, I will still be talking about chemistry because I don't have any other topic to talk about. Alright, so in this episode, I'll be talking about or discussing the three states of matter. Is it? Um, it's about matter. Okay, introduction. So, matter. Matter exists in three physical states, like gas, liquid, and solid, and most people, students, know this, especially scientists, chemists. Alright, so the simplest form of matter is the gaseous state, and, well, because the gaseous state does not have a definite shape and volume, and it occupies all the available space, and, well, their intermolecular forces are very weak. Alright, and so yeah. Oh, and another thing about gas is that pressure is its significant property. So yeah. Liquids are less common. They have strong intermolecular forces. They have definite volume, but they don't have a definite shape. And it also attains the shape of the container in which it's kept. They evaporate, and their vapors exert pressure. And when vapor pressure of a liquid becomes equal to external pressure, it boils. Mhm. Most of the matters exist as solid. It's rigid and denser, and it exists in amorphous or crystalline forms. Right. Next thing is diffusion. It's part of the um, gases, I think. Right. So it's a spontaneous mixing up of molecules by random motion and colloids to form a homogeneous mixture. So, another thing about gases is they diffuse very rapidly. And the rate of diffusion actually depends on the molecular mass of the gases. For example, well, because, like, or how do I say this? For example, lighter gases diffuse rapidly than heavier ones. It's a fun fact. So, yeah. Next one, effusion. It is the escaping of gas molecules through a tiny hole into space with lesser pressure. For example, like when your tire, like car tire or bicycle tire gets punctured, air effuses out. See, effusion, effuses, and it depends on molecular masses. Lighter gases effuses faster than heavier gases. Third part, pressure. Pressure is defined as the force exerted per unit surface area. Gas molecules are always in continuous state of motion, like strike walls of container other surface. They exert pressure. Alright, so things that are used to measure stuff. A barometer. A barometer is used to measure atmospheric pressure, and a manometer, if that's how you say it, it's used to measure pressure in the laboratory. And right, standard of atmospheric pressure. It is defined as pressure exerted by a mercury column of 716 millimeters height at the sea level. It's sufficient pressure. It is sufficient pressure to support a column of mercury. Um, 16, yeah. Um, anyways, the next one, compressibility. It is highly compressible, of course, due to empty spaces between their molecules. When gases are compressed, molecules come closer to one another and occupy less volume as compared to the volume in uncompressed state. Um, hmm. And yeah, I'll continue more of this in the next episode because, as usual, I don't have any topics other than chemistry right now. So, yeah, this is gonna be the end of the episode. Goodbye.